Okay, so what do you do if the project that you're working on requires a little bit of movement or animation? And there's several choices, but as you've gathered from what I have here and the title of the video, you've probably figured out that I'm going to talk about how to use a servo. Now I have an actual purpose for doing this. I have some 1/8 scale models of some Corvettes, and on these Corvettes I've got a 3rd generation and a 4th generation Corvette that I got from eBay. They have been built, but they're falling apart, and when I finish up some of my other projects I'm going to start one of those, and I want the headlights to flip up and down. And to do that I decided to use a servo to drive the headlights up and down. Not this monstrous one, but a little one like this. And hopefully I can find an even smaller one, but so far this is the smallest one I can find. Now, if you're not familiar with how servos work, you'll notice that the servo has 3 wires. You'll have power, ground, and a signal. The signal that goes to the servo is what's called a pulse width modulated, or a pulse width modulation. So again, we have positive, negative, and the signal. And again, the signal is, again, what they call pulse width modulation. And that is coming from, in my example, a 555 timer. Now, there are several different ways you can do this using like a potentiometer. For example, I've got one of these things. This is a dual pot joystick, up and down and left and right. This is a Parallax product, and it would be really easy just to connect this to a microprocessor, put a little bit of code into the microprocessor to see the position of this and then control the servo. But in the model car I want to build, I don't have a lot of room for a microprocessor. I'm going to have to build a tiny little circuit and try to hide it under the seat or something like that. So that's one reason why I chose the 555 timer. There's a few other reasons, I'll get into that later. There are also circuits that don't use the 555. They use a different ICs or different methods of producing the pulse width modulated signals. If you go online and do a search, just do an image search for servo driver, you'll get a ton of these come up. This one, for example, this comes from 555timercircuits.com. This one is from Tony Von Roon. I have no idea who that is, but it came up in one of the searches. I've got several others here that I just printed up, printed off, and to move the headlights up and down, I just need 2 positions. I need it to go up and down. So instead of using a potentiometer, for example, if we take a look at this one uses a potentiometer to drive the servo in various positions. But to just have 2 positions, we have this circuit where one button makes it go in one position, another button makes it go in another position, which is what I have wired up here. Power's not on right now, that's why it's not moving. Now in this diagram, they use 2 set values, but I wanted to be able to accurately position my 2 positions, so I used 2 potentiometers, and those are 10 kilo ohm potentiometers. So I kind of combined this circuit over here with this one down here. All right, so before I show the operation, let's just take a look at the breadboard. Now it doesn't look that good. It's all kind of spread out and a little bit messy. The reason for that is because I've been experimenting with a lot of different things. I tried using this. Unfortunately, this, again, it was meant to go with an Arduino. This does not give you full deflection. When you go one way, you don't get the full 10,000 ohms. When you go the other way, you don't get like 0 ohms. You get like 13 ohms. So you can't get full deflection with this like you can one of these. And plus, yeah, it's a little big for what I need in it. I want push buttons instead. So anyways, but I did experiment with this a little bit. That's why there's a big open space here, because I did have that mounted in right here to play around with it. But then I realized it wasn't working out for me very well. So again, just taking a look at the circuit. If we compare here, you can see we have a power rail coming in. power just goes straight to pin 4 and pin 8 through a 33K resistor, and then to pin 7. Between pin 7 and 6, we have our 2 resistances and our 2 push buttons wired in parallel. 6 and 2 are connected. Down here we have the ground rail. The ground comes up through a capacitor to pin 5, right to pin 1, and then through a capacitor into pins 2 and 6 here. The output giving us a signal is pin 3. Now in some of these diagrams, for example this one right over here, you'll notice that the output of pin 3 does not go through a transistor. See, this one goes through a resistor and a transistor. The transistor then gives us our signal. This one does not. So when I very first built the circuit, I copied this, kind of, but I realized, well, this one doesn't use the transistor, so I'll just skip the transistor. And it didn't work. And I was looking at what else is different. Then I noticed that this circuit has this diode right in here between pin 7 and 6. And so during some experimentation, I realized that if you, and see this one doesn't have the diode, which I didn't put in. If you don't put that diode in, apparently you have to run it through a transistor. If you want to skip the transistor, then you have to put that diode in here. Now keep in mind, I'm just a hobbyist. I understand the gist of what's going on here, but I'm not an electrical engineer, so I cannot explain to you exactly why you need one or the other here. But again, just through my own experimentation, that's what I realized. So I decided to go with this one and use the transistor here. Now the values of the capacitors here, this one wasn't quite right for me. That value wouldn't work for me. I'll show you what I had to do here in a second. But let's compare this to what I have on the board here. So again, over here on the side, let me see if I can zoom into that a little bit here and get that to fit. All right. Over on the side, I have my negative rail, and that just goes all the way down to here. So I brought that negative rail over along the bottom here. Right here I have my positive, and the positive, I just jump that over to here, which then jumps down to here, which then provides power here and over here and down to over here. All right, so these resistors right here would be these capacitors. Yeah, not capacitors. Yeah, it's early. These potentiometers here. These are the push buttons wired in here and here. And then the 33 kilo ohm resistor. Yep, let me get that in view here. The 33 kilo ohm resistor here would be this one right here. And this capacitor is these two right here. Again, I'll talk about those here in just a second. Obviously the 555 timer here, the transistor here. That's a little bit of a different transistor package than what you might be used to. That's in a round plastic package. Probably what you're more familiar with is more of a D shape or like a half circle shape. But that is an NPN transistor. We have the 1 kilo ohm resistor here and the 47 kilo ohm resistor right over here. The diode, if you're using it, would fit right in here, but again, I'm not using the diode because I'm using the transistor. All right, and again, this capacitor here is this capacitor right here. Now, some of these circuits don't show that capacitor. Like, for example, this one, there is no capacitor to pin 5, so I could probably remove it and it would work fine. Also, you'll notice I have a capacitor over here between my positive and negative rails, which are not shown here, but in this diagram, they do use one. Again, it'll work without it. I could pull that out and it'd be perfectly fine. Now, oh yeah, one other thing I wanted to mention. With your resistors, capacitors, other parts like that, what I recommend you do is get your stuff organized. For example, early last year, I've been doing electronic stuff for like several years now. So all of my resistors ended up just being thrown into one box, and it was just a big wad of resistors, and it took forever to sort through what I need. So what I did early last year, was I decided to kind of get organized, and I went to Staples and I got a whole bunch of these little envelopes just little envelopes like this. And I went through and I just labeled them for all my resistor values with the color code. So there's 68 ohms, blue, gray, black, and then up to 75, 100, flip through, and they just go from lowest up to highest resistance with their color codes. So whenever I need a resistor from a print, I can just flip through the box here and find the exact one. I need to do the same thing with my capacitors because they're just all over the place. Now, speaking of capacitors, this right here, supposed to be, and that's the same. Notice they put 100 in. Right over here, they have 0.1 UF, that's microfarad. Those are actually the same value. It's the same capacitor. Now, when you're looking at these small capacitors, like this one that I have right here, there's a little code. Let me see if I can find one over here. There's a 3-digit code written on them. If I can get one right here. So that one right here, I don't know if you can read that, but the 3-digit code is 104. And 104 is actually the code for 0.1 microfarad. So that's what I started with. I put that capacitor in there, and the thing just did not work. So I started playing around with different capacitance values, different resistor values, and what I found was the best thing that worked for me, instead of that, was a 0.33 microfarad. Now, I didn't have a 0.33 microfarad. I put two capacitors in series. I have a 1 microfarad and a 0.47 microfarad, and that gave me pretty close to 0.33 microfarads. And again, those are these two capacitors right here wired in series. Okay? So if you're going to be building a circuit like this to control a servo, I highly recommend you breadboard it out first instead of just going right to printing your circuit board. Because again, as printed on paper here, it just didn't work very well. And plus, by using a breadboard, you can really experiment with different resistor values, capacitor values, different switches. And you know, I could carry this on several. I could put as many potentiometers and push buttons as I want on here and have several multiple step positions. So let's show you how this works here. So if I apply power and I just push this button, it goes to that position. If I push that button, it went to that position. Now, actually I let go too soon. It should go to that position. Okay, so I have this and that. All right, now, if I just hold a button pressed and turn that potentiometer, and I'm kind of having to apply, here we'll do this one, and I turn this potentiometer, I can put that servo by turning that potentiometer wherever I want it. And wherever I leave it, say right there, for example, if I leave it right there, anytime I push that button, it'll go to that position. If I do this one, and I turn this one, say, to here, now I can have those two positions set. So I press this one, goes here, that one goes here. Okay? There's a little bit of growling going on. I'm hoping that's just the servo. This is a really old servo. It's probably older than I am, I don't know. So I'm hoping it's just the servo. Now this is a very simple circuit. The one I chose to use right here. It's about the simplest you can find online. There are others that use a lot more components. They have several potentiometers. Say, for example, this one only has one potentiometer. I've seen circuits that have like 3 potentiometers, one for fine-tuning each end stop, and then one for controlling it. I'm assuming that circuits with more components will give you more control, but that's just up to experimentation. Again, my point of showing this is just to demonstrate one method of controlling a servo using a 555 timer. And again, just for driving headlights up and down, this will work perfectly fine. Okay. Again, I'll need more throw on it, but you get the idea. Now, there are other methods of controlling servos. Another very obvious method would be to use a RC receiver transmitter. That would definitely work, but then you have to have a transmitter in your hand controlling whatever you're wanting to do. But obviously they've been doing that for years with RC cars and airplanes and helicopters and stuff. That's just the standard way of controlling a servo is with a radio control unit. Another method is to use something like this. So that is a servo recorder where it lets you, you can use those knobs to position the servo and while pressing record, and then when you press play, the servo will then play back the whole sequence that you put into it. So again, that's another option. So anyways, like I said, my main point of this video is just to kind of show you this, to demonstrate this, and for those of you who that's all you came here for, feel free to end the video now, because I'm going to spend the next several minutes talking about my future plans for this. And I have another idea for controlling servo. So if you don't care about my future plans, feel free to go away. If you do want to stick around, you don't have anything else to do and you're really that bored, then by all means, hang around. So for those of you that are sticking around, thank you. I appreciate it. So I already explained one purpose, and that's for raising headlights up and down on my model car. But I have another idea for this whole servo controlling thing. And it has to do with that servo recorder that, that I just showed you a few minutes ago. I want to try to build my own servo recorder. Now, there are obviously a couple of ways that, that could be done. I'm going to show you my method, the way I'm going to try to do it. Obviously, probably the best way to do it would be to use a microprocessor like an Arduino. Like I said, I've used Arduinos, I've used basic stamps in the past. I'm not against them, but I typically try to do things without them first. I'm not the best at writing code. And I know a lot of you out there have never used microprocessors, so anytime you can build a circuit without using one is beneficial, possibly. Also, I would rather spend my time building than sitting in front of a computer writing code. That's just me. If you're more of a code person, then by all means, use a microprocessor. So when I'm done with my circuit, it will probably be about 10 times the size of an Arduino and have maybe half of the capacity. But still, it's the way I'm deciding to do it. So if you want to put in the comments how using an Arduino would be so much easier, that's fine. I already know that, but feel free to comment anyways. So the goal is, the plan is, to start off with a potentiometer. Now on that servo recorder that I showed you a few minutes ago, they have 4 potentiometers. It's capable of recording 4 servos at the same time. Now that potentiometer will go into an analog to digital converter, or an ADC. What that does is that kicks out an 8-bit word. Was that 1, 2, 3, 4, 5, 6, 7, 8? That kicks out an 8-bit word. Now you can have as many bits as you want. 8, 16, 32, whatever. I'm just using 8 for manageability purposes. All right. And an 8-bit digital word will give me 256 servo positions. I think 256 positions of a servo should be plenty. So I need to take that 8-bit digital word and I need to remember it. So when I press the record button, I need to put that into memory, which will more than likely be an EEPROM, which is an electrically erasable, programmable read-only memory. So once all those positions are captured in the memory, when I'm ready to play, those 8-bit digital words will then go out to a digital to analog converter. From the digital to analog converter, we go to the 555 timer circuit that I just built, and then to the servo. Make sense? Obviously, this is just a flow diagram. It would require a whole lot more than this because I need to be able to control the read and write functions. So instead of doing one video showing how to build this entire thing, I've decided to break it down into smaller chunks. And I don't know when I'm going to be able to work on each individual smaller chunk. Right here, I just did this part of it right here, so I'm already a little bit done. But before I wanted to start on any of this, I wanted to verify, I wanted to make sure that I could control a servo. So probably the next step would be to make the digital to analog converter. That way I can tie this into the 555 timer and just manually put in 8-digit or 8-bit words and drive the servo. And then I'll work backwards until I have a complete circuit. And as I said, I am fully aware that a microprocessor would be able to do this so much more elegantly and in a smaller package, but I don't care. I want to build this. I want to try this. This is actually an idea that I had probably 10 or 15 years ago. And before I even knew that one of these actually existed, I'm just now getting around to actually playing around with it to try to do something with it. I don't really have a project in mind to use this for. I just want to see if I can do this and make it work. So hopefully in about 3 or 4 more videos, we'll have a complete functional unit, I hope. Like I said, I don't know how quickly I'll be able to get to each of these. I've ordered components that I need for this. They're coming from overseas. I probably won't get any of these until January or February. But anyways, that's the plan. So I've been talking and rambling for quite a long time now. I do appreciate you guys hanging in there, sticking with me. Any thoughts, comments, questions, feel free to put them in the comments. As I said, this is a little bit growly. It's not perfectly smooth. I tried putting capacitors in here, trying to smooth out the outboard signal, and with not much luck. So if you have any ideas as far as how I can improve this, if you have a link to a better circuit than the one I used, feel free and share that, because I would like a nice output on my servo, final output on the servo. So anyways, like I said, I'm going to stop talking. I've been going on way too long now. I've said that already. And, you know, it's too cold to do any painting, so some of my other model projects are on hold for a little while. But when those are done, I'm going to start on one of those Corvettes. And when I start on those Corvettes is when I will probably make a circuit board for all of this. And I'll probably use surface mount components so I can make it really small and fit it under the seat. But anyways, just something to look forward to and give you the heads up what I'm doing, what I'm working on. And yeah, until next time, as always, thanks for watching.